Close your eyes and picture the birth of calculus. You probably imagine Newton under an apple tree or Leibniz writing with a quill in 17th century Europe. Now open them, because that's only half the story. For generations, the world believed calculus was a European invention. Meanwhile, India was reduced to a footnote, a land of ancient temples, mysticism, and the number zero. But centuries before Newton, on a tropical coast of Kerala, Indian mathematicians were exploring infinite series, calculating the value of pi with an astonishing precision, and developing ideas that look strikingly like calculus. And then 300 years later, a self-taught clerk from Tamil Nadu, who claimed a goddess revealed equations to him in the dreams, would actually send a letter so shocking in Cambridge that professors there first thought it was a hoax. This is the hidden 300-year-old thread connecting Kerala school to Srinivas Ramanujan. And by the end of this story, you will see why history of mathematics needs to be rewritten. And that's what SciAstra is all about. We are bringing those hidden Indian gems to the masses in public. And if science, mathematics, or technology intrigues you, and if you're preparing for IIT, NEST, JEE, NEET, then check out all the batches by SciAstra and the community support that we have, which spans over 5 lakh students across the world. To know more, check the description. To understand this story, we have to go back nearly 2000 years to the Malabar coast of Kerala. And that was one of the world's greatest ancient trading hubs at that point in time. That was a time when Roman coins used to lie like that on the ground. And there were Greeks, Arabs, Africans, and even Chinese sailors who mapped their routes to the ports of Kerala. They mainly came for the spices, especially black pepper, the famous black gold at that time. But they also carried back something even more valuable: ideas. And Kerala blended those global influences with its own ancient Vedic mathematical traditions, precise astronomical practices, and a culture of temple scholarship. There were palm leaf manuscripts, preserved knowledge, and the kings who supported mathematicians and astronomers at that time. It was a rare combination. There were international exchanges, indigenous science, and active patronage, which created the perfect conditions for a scientific revolution that the world forgot. Around 1340, a mathematician named Madhava faced a challenge. Astronomers needed more accurate trigonometric values to predict the eclipses and planetary motion. To solve it, Madhava made a discovery centuries ahead of its time. He expressed sine, cosine, tangent, and even pi as infinite series, which we now know today. He found out that pi by 4 is actually the summation of 1 minus 1 by 3 plus 1 by 5 minus 1 by 7, going so on, which was actually used to study the trajectory of a planet. His students expanded his work. Neelkanta Samyaji proposed a partially heliocentric solar model decades before Copernicus. Can you imagine? Jasdev wrote the Yukti Bhasa in Malayalam, the world's first textbook explaining calculus like ideas with proofs. These were the conceptual foundations of calculus, which was discovered 200 to 300 years before Europeans found it, but written in Sanskrit and Malayalam, buried in temple libraries and dismissed by colonial scholars. Their genius remained unknown to the world. Srinivas Ramanujan was born in 1887 in Tamil Nadu. A prodigy by age 10, he mastered advanced trigonometry by age 13 and discovered his own theorems by 15. But he failed college. Not in mathematics, but in English and other subjects, which actually forced him to work as a clerk at the Madras Port Trust. And this is where things become interesting. At night, he filled notebooks with thousands of original results. Ramanujan said a goddess, Namagiri, revealed mathematics in his dreams. There were scrolls of light filled with equations. He had no formal training, no proofs, no mentors, just raw, explosive intuition. In 1913, desperate for recognition, he wrote a 9-page letter to G.H. Hardy at Cambridge. G.H. Hardy was a famous mathematician at that time. It contained the results so unusual that Hardy first suspected a hoax. But once he examined them with J. Littlewood, both realized these could only have been written by a genius of the highest class. Hardy soon found out it was Ramanujan from India. He invited him to Cambridge, and crossing the ocean at that time meant breaking the caste rules, until Ramanujan's mother dreamed that a goddess told her to let him go. And in 1914, Ramanujan arrives in England. Hardy was a man full of logic, rigor, and structure, and Ramanujan, on the contrary, was intuition and revelation. Together, they transformed number theory and worked on patterns that are still used in physics, cosmology, and astronomy today. Their partnership produced some of the most beautiful mathematics of the century, many of which we are not even able to leverage fully to this date. And this final discovery, the mysterious Mach theta functions, lay dominant for more than 80 years until physicists realized they appear in equations describing black hole entropy, which was very hard to study. In modern research on quantum gravity, Ramanujan's fingerprints are almost everywhere. Today, many physicists say that Ramanujan does not just do mathematics, he somehow saw the mathematics of quantum world long before science had the language to understand it. But wartime England, strict vegetarianism, and harsh climate collapsed Ramanujan's health. He returned to India in 1919 and died a year later at just 32. In that short span of life, he produced nearly 4,000 results, many still being proven today. Hardy ranked mathematicians on a scale of 100, where Hardy put himself at 25, Littlewood at 30, Hilbert at 80, and Ramanujan at 100. Did Ramanujan know about the Kerala school? Historically, no. Even his infinite series for pi was discovered in the 1910s. Turned out to have a future he could have never imagined. These series are now used in quantum computing algorithms, high precision simulations, and cryptographic systems that we use today. A small notebook in Kumbakonam ended up shaping the mathematicians behind today's most advanced technologies. But the fate had its own way. Their manuscripts were forgotten, untranslated, and inaccessible. There is no evidence he studied them, but the similarities are uncanny. Both traditions embraced infinite series, fearless intuition, and deep comfort with infinity. Both treated mathematics as a blend of logic and spirituality. This is the best part. Both emerged from Indian cultures where temple astronomy and philosophical ideas normalized the concept of infinity. Although Ramanujan never mentioned Madhava, but he inherited the same civilizational mindset, where calculation, intuition, and cosmic thinking intertwined. Even more striking, some of Ramanujan's series for pi resemble the Kerala method. Whether independent rediscovery or cultural echo, the resonance is too strong to ignore. For centuries, textbook told a narrow story. Calculus was born in Europe. Modern mathematics is Western, and Ramanujan was a lone miracle without roots. This version erases global mathematics and diminishes non-European contributions. Restoring Kerala to the timeline shows that calculus had multiple birthplaces. It proves that mathematical genius is not just European or Indian, it's human. It lets Indian students see themselves as inheritors of a deep intellectual heritage, not outsiders to a foreign tradition. This is not a competition between civilizations. Newton and Leibniz transformed mathematics with notation and generalization, but India also made profound foundational discoveries. Recognizing this does not diminish Europe, it completes the global story. From palm leaf manuscripts in Kerala to Ramanujan's fragile notebooks, India contributed some of humanity's deepest mathematical insights. Yet much remains untranslated, unexplored, and unknown. The lost notebook still reveals secrets. Kerala manuscripts still sit unread. How many other traditions across the world hide similar brilliance? How many Ramanujans are being ignored today because our systems value certificates over creativity? Mathematics was never created by one civilization, one culture, or one genius. It is a universal human story with voices we are only just beginning to hear. And perhaps the greatest irony is this. A clerk from Madras wrote equations on cheap paper that now guide physicists exploring black holes and the quantum universe. But the question remains simple. Are we finally ready to listen?